Welcome back. In this video, we will take a simple arrow shoot and polish it with 𝒖𝒓. There's a lot to cover, so let's dive in to the tutorial. In this setup, we have a Sparrow character. When I left click the mouse, it will play this montage. I'll click this search icon to browse to that animation montage in the content browser. Let's open it up. I am going to attach our Niagara system to this animation. We'll be creating two Niagara effects, one for loading the arrow and another for shooting the arrow. So back in content browser, I right click and create a new folder. Call it 𝒕𝒉𝒐𝒖𝒓. Inside it, I add a new Niagara system. I'll start with a directional burst emitter and name this system ns_Sparrow load. Let's open it up. By default, this emitter shoots out particles in a burst. We are going to modify it to create a spiral motion. First, I'll rename this emitter to spiral. Now, let's clean it up. I remove the gravity, drag, scale color, scale sprite size by speed, and add velocity modules. We won't need them. Here I set the particles spawn count to 10. Next, go to the particle update section and add the rotate around point module. Set the radius to 200. When you tweak the face, you'll see the particles start rotating in a circular path. Currently, all the particles start from the same point. To distribute them evenly in the circle, click the arrow beside the face input, search for index, and choose Return Normalized Executing Index. Now the particles are evenly spread around the rotation point. To move these particles towards the center point, I change the radius to float from curve. Now it goes from 1 to 0 in its lifetime. I can change the start Y value to initial radius, but I can do the same easily by changing this scale value. I set it to 200. Now particles are moving inwards. To rotate them, I set the rate to 1. In the emitter state, set the loop duration to 0.4. They are moving at different speed due to their random lifetime. So here I set the lifetime to direct set and set it to 0.4. Now all the particles move at the same speed, creating a smooth, fast spiral effect. Now let's transform our spiral particles into a glowing spiral ribbon effect. So I right click and add an emitter. I select this minimal one and add it to the setup. I rename this new emitter to spiral ribbon. In the emitter state, I set the loop behavior to once, fix and set duration to 0.4. Same as our spiral emitter. So to generate the ribbons out of our first emitter, we need to transfer some data from it. So in the spiral emitter, go to particles update and add generate location event module. Move this module to the bottom of the stack to ensure it executes last. To fix this warning, go to the emitter properties and enable requires persistent IDs. Now to use this in our other emitter, click this stage button and add event handler. There, set the event source to the first emitter's name and set the mode to spawn only. Then click this plus button and add receive location event module. Back in the event handler properties, set the spawn number to 1. Now you can see we are spawning a particle every time the spiral emitter sends a location update. Here I set the lifetime to 0.4. Since we aren't going to render this as sprites, disable this and add ribbon renderer. Then back in the initialize settings, set the ribbon width to direct set. I give it a 20. And just like that, we have the spiral pattern we were looking for. To give it a color, I am setting the color mode to direct set and give a nice yellowish tint. To make it glow, I bump the value to 10. Since I'll use this color in multiple emitters, I drag and drop it to here to save it. You know what? I'm going to push this value to 100. In particle update, I add scale ribbon width module. This will multiply the initial ribbon width. Here, convert this to float from curve and select this template. Then I add scale color module. Change this alpha to a float curve and select that same template. I'll adjust the graph a bit. Now let's add this to our montage to see how it looks. Add a new track, right click, add notify, play Niagara particle effect notify. I put the notifier around here, right when the player starts to draw the arrow. Then in the details window, select the Niagara system we made. Now you can see the effect in the montage, but not where we want it. To attach this to the boss drawing location, I go to the character skeleton mesh window and add a preview animation. In this skeleton, there's already a socket named arrow anchor, and it is right where I want it. So back in the notifier, in the socket name, I type the socket name we want the effect to attach to. It's still not giving the results we want. That's because here in the first emitter, by default, the rotating center is set to 0, 0, 0. So I click here and search for simulation position and link it to the rotating center. Now it is spawning at the right location, but still rotation is off. So back in here, I disable this derive the rotation axis and set the axis to Y. Finally, it is working. Let's play this. When I left click, it shoots and reloads the next arrow. But yet again, our axis is wrong. For that, here in the first emitter, we have to set this to local space. Now it is working, whatever the direction we faces. I like to change the material a bit, so let's use something from the starter content. Back in the content browser, select content and click this plus. Select add feature or content pack, and I add the starter content pack to the project. In there are a few materials we can use for this effect, like this radial gradient one. Since I don't like to change this original material, I copy to our Archer VFX folder. I rename it so we can identify it clearly. This is what the material is look like. Now back in Niagara system, I actually don't want to see the particles generated by the first emitter. I want them only to drive the ribbon emitters. So I disable this sprite renderer module. Then here in the ribbon renderer, I change the material to the one we edited. I will make a second layer of this emitter. Duplicate this. Increase its ribbon width. I see a bit of artifacts in the ribbon, so in the render settings, I increase the width segments. Also, reduce the glow strength to something like 10. Now we have something like this. Let's add a few more emitters to polish this even more. Right click, add a new emitter. Select simple sprite burst. Set the loop duration to 0.5 and spawn amount to 40. lifetime to random 0.4 and 0.6. Add a shape location module and select ring/disk. This will spawn particles in a ring shape. I change its radius to something bigger than our spiral radius, like 300. Give it a bit of disk coverage. To adjust the rotation, I change this to axis angle and set the axis to Y. Then, to move the particles inwards, I add a add velocity module. Set it to from point and set the speed to -400. Set the sprite size to random non-uniform and set its min and max to 0.55 and 120. Now particles elongated. To align them to the moving direction, in the renderer, I change the alignment to velocity align. I add a glow color as well. Increase it to 100. I also change the emitter to use GPU and set this to fixed. They are currently converging to a point slightly below. That's because our socket is moving. I couldn't set this to local space, which seems to be fixed, but I don't like how the particles move at the beginning, so I disable the local space and add a slight offset to the velocity origin point. For scale color, I use this curve template. For some reason here, when I rename the emitter, it stopped working, so I guess we have to keep the original name. Let's add another emitter that flashes when the particles converge. I add a single looping particle emitter. Set it to GPU, emitter state self and 0.2. But I want it to spawn right after our spirals and particles converge, right about here. We know that particles converge after 0.4 seconds, so let's set that as our loop delay for this emitter. In initialize particle settings, I don't need to change the lifetime. It currently linked to the loop duration. So I change its color to match every other emitter. Add scale sprite size module. This will multiply the sprite scale over its lifetime. So to make that flashing look, I select this template. That way particles will scale up and goes back down. I set the sprite size to 50. Add a scale color module. Set the alpha to float curve and select this template. And adjust the handles a bit. Wouldn't make a huge difference in this case. You can disable this if you want. Now I select the material we copied from the starter content. Let's make our next Niagara system that triggers when shooting the arrows. I add a new Niagara system. Select the single looping particle and hit create. Rename it to ns_Sparrow shoot. In the first emitter, I set the looping to self 0.3. Set the color to the one we saved. Set the sprite size to something like 30. Then add a scale sprite size module. Now back in our montage, right around here when the character shoots the arrow, I add a new notify. Play Niagara particle effect and select the Niagara effect we just made. Assign the socket as well. We get the burst effect. Back in the emitter, I set the curve scale to 3. In starter content, we have another material we could use for this burst one. I copied to our folder. Inside it, we have this dynamic parameter module that we can adjust to change the effect. Here, when I change this R value to 1, we get something like this. So let's use this for our emitter. To change that dynamic parameter value, here in the particle update, I can add dynamic parameter module. I disable other parameters and change the first one to float curve and select this template. Select this key in the curve and set its X to something like 0.6. It is too small at the moment, so I change this curve scale to 5. Add a scale color module. Change it to float curve and select this curve. I tweak it a bit like this. At the moment it always looks the same, so here in the initialize settings I add a random rotation. Now the burst looks slightly different each time. Just like before, I want to add another layer of this. So duplicate the emitter, change the loop to 0.4. I double the particle size. Actually, here in the sprite size module, let's make the sprite start at a scale of 1. I set the first key to 1, 1 and set the second to 1, 2. Do the same for the other emitter as well. Now it looks much better. Let's set this back to 3. Also in our first emitter, I set the glow strength to 100. When the arrow is short, I want to add a particle burst, so I add a new emitter. Pick omnidirectional burst. I keep the loop duration at 1. Spawn count to 50. Lifetime to 0.8 and 1.5. Set the color. Sprite size to 0.5 and 1.5. Decrease the gravity to -400. I increase the velocity to 400 and 600. I disable the scale sprite size module. I think that's enough for this effect. Then I want to add a few rings that shoots forward. For that, add another emitter. I pick the simple sprite burst to start things. Set the loop duration to 1, and for the lifetime, I link it to the loop duration. Set the color and I increase it to 100. Increase the sprite size to 80. Then add velocity module. Set the velocity to 300 on Y. Set to 0. In scale color, I adjust the graph a bit like this. Add a drag module for some resistance. Set it to 3. In the sprite renderer, select the burst material. In particle update, add scale sprite size module, and in the curve, set the first key value to 1 and the next one to 2. I can change the handles to auto and smooth the curve like this. Now if I play this, it is working except for the orientation. It always facing the camera. I want it to face the firing direction, so in the sprite renderer, I set the alignment to custom alignment and facing to custom facing vector. Then in the particle spawn, we can declare that vector. So add sprite facing and alignment module. Set the vector to Y. Set the coordinates to local. Now you can't see it for some reason. Oh wait, that's because in material settings, it is visible from front but not from back. So in the material, enable this two-sided option. Now it should be visible from all angles. Also in the material settings, I reset the refraction. We don't need that for this material. Let's add a few layers of this. I duplicate this. Set the loop duration to 0.9, size to 50 and velocity to 450. Duplicate it again and set the loop duration to 0.8, size to 30 and velocity to 600. Now we have 3 rings and it got a bit of punch to it. That's almost it, but just to add a bit of icing, I add another emitter to cast some light to the surrounding. I select a single looping particle, set the emitter state to self and loop once, duration 2.3. Set the color. I increase the glow to 100, sprite size to 150. Add scale color module to control the alpha. Set the alpha to float curve and select this template. Adjust the handles a bit. In the renderer, I add a light renderer. This will cast light to the surroundings from this sprite. I don't want the sprites to be visible, so disable the sprite renderer. In the light renderer, disable use inverse square follow. Enable alpha scales brightness, radius to 2 and exponent to 4. Now if I play, you'll see when the arrow is short, there's a quick burst of light around the character. You can see it clearly if I go to a bit of a dark area, near this pole maybe. You can add this to our other emitter as well. Just copy the emitter and paste it there, or just make it from scratch. Here, I just increase the loop duration to 0.5. Set the size to 100. I choose this curve for scale color. Adjust it a bit. And the same values for the light renderer. Disable the sprite renderer. Now we have that light when we load up the arrow as well. Also, if you want the spiral to look more random, here in the first emitter we made, you can change this rotation rate to a random range value. This will randomize the amount of rotation each point does, which makes the spiral look random. And that's it. That's how you make this arrow shoot effect in Unreal Engine Niagara. You can polish this even more with sound effect and some camera shake, but that's for another video. As always, you can grab the project files from my Patreon page. Don't forget to hit that like button and subscribe to the channel. You can find quite a few Niagara tutorials and Blender Geometry Notes videos on this channel. So, until next time, see you soon.